Hello everyone, today I want to introduce my new method for the AUV buoys in rope detector. And in this first image you can see this original method. The KNN method try to detect the movement of the between frames. So sometimes it means detect the buoys. And this is the KNN detector. So I want to improve the stability. So I use the HSV detectors, and as you can see my buoy detection and AUV is quite stable, and I can give the suggestion diving point, also the flight direction vector for the drone. And here is my methodology. I have the three detectors: buoy detector and SAMS AUV detector and rope detectors. For the buoy detectors, I crop the colors and find the maximum contour, and also check the security. And this is optional. You can uncomment the code because now I command it is because it's quite stable. It can detect the buoy, the center of buoys, and also their function like dilation and erosion can be applied for the more complex environments. And the next, I detect the AUV, and AUV I also crop the colors and find the maximum contours. And I further check the height and width ratio. When it's over the 2.5, is recognized as the missile-like shape. And this way I can also detect the center of the AUV. And these two methods, you can choose one of them to give the center of the contours, and then we can find the center of AUV. And once we find the center of the AUV and the buoy, we want to make a connection and give the suggestion diving point. So after connect that, I also give the vertical vectors and also the 0.2 meters offset. That's just to prevent if the drone want to put his anchor or hook into the water, it will not just directly hit the rope. And after that, for the rope detector, I also crop the colors and I try three different rope reconstruction, like a KNN sorting or Y-axis sorting. Since the rope detection by color is more challenging because it's thin, and also water reflection will cut this light. So after that, I try to use the dilation and also the unframe combination. After combining, you can see the in this image on your left hand side can show the rope more better than just one frame, and then do the dilations. And there's still some segments, so I tried this spline line and polynomial line connections. However, it requires the sequence in orders. So that means if the rope sometimes curve complicated, it may connect wrongly. So to prevent that, in the end, I tried the polynomial functions. And before that, I also tried the grid-based connection like an A-stop. However, A-stop requires all segments need to be connected, so it doesn't work well. So in the end, I tried the polynomial function, and you can set the 3-degree or 4-degree polynomial. I want to do it autonomously because I know when the buoy is close to the AUV, that means the rope may be displayed in a more complex pattern. So we can increase the degree autonomously from 3 to 4 degrees. And after do the polynomial function curve fitting, I can get the stable heading line, stable line, and get the middle of the point, middle of the line, we can get the suggestion heading point. So please compare the original methods. Now it's quite stable, from no matter the buoy or the AUV and also the catching heading point. Now let's try a little bit disturbance and move the rope, and we can get the good diving point and heading point. The diving point is for the quadrilateral to put is the hook into the water, and the arrows can suggest the quadrilateral how to move in which directions. Let's try to move another curve like this, and also let's try more challenge like make it a circle, and sometimes it will like this a circle and it cannot detect very well, but it will give the like roughly suggestions. In this case, I want to do next step. I want to do like a CNN training, human labeling the suggestion, probably the anchor in this position, and then by training of that, we can have our decision tree will be like in the beginning. If the distance between the buoy and AUV distance is good enough, we can do it at this heading point directly hooking, and if not, we will use our CNN network and use the human experience to give the drone suggestion where to put the hook. In this circle entangle part, we should put the hook in this circle. I think it will be the best solutions and move in this direction. Okay. So let's try this. Okay. Thank you very much for your watching.